Welcome to Ecologic for the month of August. Beautiful time of the year. Big full moon last night. Got to enjoy that. Camping out with the scouts on the Schoeffler River. To share with you that the Mississippi River Commission had a public meeting Friday. And some of the prominent issues we're dealing with the levee system in Terrebonne Parish, that they have about $1 billion of local money being put into that, thanks to BP. But one of the astonishing admissions from the Corps and the Mississippi River Commission was that the Schoeffler Basin cannot carry the project flood. And it's kind of scary because if it can't, then it's going to go somewhere else, and maybe it'll go where we don't want it to go, into New Orleans, into Baton Rouge, into a lot of other places. So, matter of concern. We're fortunate to have with us Luke Connor, with CPL here in Lafayette, who's has a long history of working with renewable energy all across the country. And he's going to share some of those ideas and concepts. Some of it may apply to our needs in Lafayette moving in a new direction. So, Luke, thank you for being here.
Yeah, thank you, Harold. Thanks for having us on board.
Luke, you might share with us, I know you're involved in biomass project. You'll have that, I guess, in Topeka, Kansas. You'll have a cow manure project. I know you have waste heat recovery, and probably a lot of other options y'all are dealing with in providing the electrical needs of various parts of the country. But I think it's important to mention your efforts in landfill gas and recovery of landfill gas, because there's an opportunity for renewable. It's very low cost. It's readily available all over the country. So, thank you for being here.
Yeah, Harold, we've been a quiet little company here in Lafayette, but you'd be surprised to hear the names of some of the folks that we do this type of work for. Everybody's, you go in your kitchen and you have Kellogg's Corn Flakes and Coca-Cola and PepsiCo and Frito-Lay and Tropicana, all those folks. Everybody uses energy, whether it's steam or electrical generation requirements. But we've also, because of being right here in Louisiana, we've done a considerable amount of biomass work, and still today we are heavily involved in, the wood industry's kind of having a resurgence, and they're moving along, and there's a lot of that equipment that's in East Texas and all over Louisiana, and their only source of energy is wood chips and their power. I mean, they power the entire facility off of it. And
so their waste powers their needs.
Absolutely, and
wow.
They're 100% dependent upon waste energy, and with the new clean air requirements, we help them out. And the fact of the matter is that wood chip is now becoming a valuable resource, because as more and more biomass to power projects come online, then there's a bigger demand for it.
I understand Lafayette sells a lot of their yard waste components into that market.
Well, there's a lot of, you would think, how in the world could you support a biomass power plant in the likes of, Tucson, Arizona, or Topeka, Kansas, but majority of it comes from grass clippings and
yard waste,
tree limbs.
In Lafayette, it's 35% of the waste stream, and we've been recycling that for years. And a good part of ours, I think a third of what we get, is going into feeding the needs of lumber mills or plywood mills up in North Louisiana. So. Yeah. There is a daily source almost of biomass. And you think we produce in Lafayette, I think it's 150 tons a month, maybe 200 tons a month. But a city like Houston would be phenomenal, what they would produce. Because, I mean, they have the same grass growing, the same trees, same limbs falling, and so forth that we have here in Lafayette. But they got almost 5 million people. And so... you think of energy, wow.
The opportunities for biomass are pretty It's pretty limitless. I like in Casa Grande, Arizona. You go out there and you would think it's nothing but a desert, but you know what? We can produce about 3 megawatts of electricity, and it's for a Frito-Lay power plant right there out in the middle of. I mean, it's very dry, but we get pecan shells, waste pallets, and we get yard waste from Phoenix, and it powers that plant. I mean, between that and a big solar project, we're almost off the grid. That's one of the projects we tried to get this facility completely off the grid, and it's close.
You know, our percentage of self-generation in this country is very small compared to Germany. Germany is almost 40% self-power. It also turns on this issue of cost, and I think public relations plays a role in it, because you want to do a business with a company that's green, that cares about the earth that we all live on.
Yeah, and the Europeans have a little different philosophy, and I think we lost some of that here in Louisiana because we have so much vastness of land is almost limitless, and in Europe they'll put a power plant right in the middle of town, and the reason for doing that is you don't just generate electricity, you generate chill water for everybody's air conditioning, or you generate hot water. So instead of having a cooling tower out there rejecting 65% of what you consume to the atmosphere just to condense water to put it back into the system, you run an absorber to make chill water, so that's what everybody's air conditioning runs off of, or you generate hot water and you run that through town. But
and you heat homes with the hot water.
That's called central utility, and
Indianapolis has that.
Absolutely, and we've worked with that plant and did a landfill gas to energy job with it.
Wow.
In the old central utility plant right behind the stadium there.
That is amazing, because I knew they had a public utility that distributed hot water, and it comes to your house, it goes through radiators, because you want nothing safer.
And
really super safe.
Their energy generation, of course, and they also burn. They had a big pipeline that there was an old coker unit out by there that we ran coker gas to it. They similar to the project down at Cabot, where they're using waste heat and waste gas off a coker unit to make power, and what's 50 megawatts that they're producing.
Yes, 50 megawatts. And it's a real cost-effective project, and they're copying that at the Ville Platte, the carbon black plant.
And
carbon black is burning natural gas in a incomplete combustion process that produces a lot of soot, and that material is the raw material product for synthetic rubber. We all use it. It's our tires.
Yeah, I mean, when you it's just like taking a propane torch or a cutting torch and lighting it and not having enough oxygen on it with that black soot that comes off of. That's exactly the same process. You're just burning fuel without enough oxygen, and instead of making CO2, you're making CO, which is still a combustible fuel.
Yes.
And there's a lot of hydrogen too that comes off of that, and it's a perfect fuel. And they burn it in their furnaces, and these furnaces run at real high temperatures, but they're rejecting a lot of that heat, so, and then, you can't just let the carbon monoxide go to the atmosphere. You have to destroy it. So what they do is they'll run it through a big furnace. They'll take some of the heat off of it, but you're still exhausting at 900 degrees. That's a lot of energy, and there's a lot of airflow.
A lot of energy that you can produce steam, produce electricity at very low cost.
Just think how many years that plant's been running. How many?
I know it's been there almost 50. It's been there 50 years.
I believe it has.
Yeah.
Louisiana had a lot of those little plants around because they didn't just make coke off of natural gas. It was off of distillate and oil,
Yes,
white oil.
yes,
I mean, there were
yes.
a lot of them around.
And I think we have 4 of them in St. Mary Parish.
Yeah.
Yeah.
Yeah, absolutely. And that's a big part of what we've done over the years with people. Landfill gas is a very interesting waste product. There's tons of landfills.
Share with the audience just how you hook into a landfill and get something out of it. And I hear that, in Mexico City, kids go with a white pipe and they stick it into the waste and then they light it, and that's how they see.
That's so they can dig at night.
They can dig at night.
Yeah, absolutely. I mean, landfill is, no different than what really happens naturally with Earth, as vegetation or carbon waste as rots and destructs, it gives off methane gas. And actually, methane is a very, very good fuel because when it burns, it burns very complete. And the interesting thing about how to reduce the emissions when you burn a fossil fuel, you mix it with a little bit of carbon dioxide and to control the temperature, and that reduces the NOx emissions. So you have a built-in NOx reduction plan with this landfill gas.
Because this is it eventually escapes, and it's a greenhouse gas.
Oh, absolutely. And part of what happens with a landfill is you are required to capture this gas because it is very smelly, for one thing. It does have a good odor, or significant odor. So you have to catch it, destroy it, and the majority of it in the past has been flared.
Yeah.
So what we do is,
Or just escapes.
well, you can't let it just escape anymore. You have to drill a well in the perimeter of the landfill and across it and capture that gas and then destroy it.
How long will one of these old landfills produce?
Well, we've been working with we've been around for 20 years and fooling with it, but some of these landfills are still going pretty strong. So the natural curve on a landfill, it takes about 3 to 5 years for it to really get up to speed and generating, and it'll last another 17 to 20 years. And the problem with some of them is you design the equipment so that you can use the gas when it's at peak gas generation. Then as it begins to tail off, some of the equipment has to get modified, but we continue to use it way on down, way into the late years.
Wow. Now, how long after a landfill is no longer functioning do you have for it to still produce?
Well, that's all part of the natural cycle. Yeah, I mean
So as long as it's active, you're producing, but when you shut the unit down, you may have 10 years left to still?
when you shut it down, no, you have a good 17, almost 20 years. And right now, our project in Memphis, Tennessee, at South Shelby, we have 100 years of waste space.
Wow.
So our project will go well beyond. I'll be growing daisies long after that.
Wow.
And right now
So these are long-term solutions.
Oh yeah,
And the technology is continually becoming more, just like wind or solar, is becoming better, more efficient, more dependable as we get experience. Am I right on that?
yeah, you want to talk about dependability and reliability. We did the Goddard Flight Center project for NASA at Goddard Flight Center. And the reason being was they got curtailed on diesel fuel. They couldn't burn diesel. And the Hubble was up in the air one winter, and they got curtailed on natural gas. So they couldn't keep the refrigeration running to keep the Hubble going.
Wow.
So we connected them to a landfill so that they would have reliable power. And they still are running Goddard Flight Center off of landfill gas.
Wow.
First federal government funded.
Now, I've heard numbers like we have 3,000 plus landfills in the country that have commercial quantities of landfill gas, but we've only tapped it into 400 or 500?
About 600 to date.
Wow.
And, the unfortunate part of landfill gas is you got to have a landfill next. You got an energy source, you got to have a load.
A need, right.
A need for
sure.
it.
Yeah.
And then
What
you
they call it a
can't
sink.
you got to have a sink. So, generating electricity sometimes becomes a challenge because you don't have a load for it. So there are other technologies becoming available today where you can actually make near natural gas quality a fuel and put it into a pipeline. And there's a couple of
do
those.
they blend it with regular natural gas? Is that something else an option?
And it is possible to, if you got a big enough pipeline, you can put it right in the pipeline, and it just takes a little compression and some cleaning up, and they'll go right in the pipe.
Wow. Is it landfill gas that the Jenbacher engines were developed for, the super efficient engines?
Well, the Jenbachers can burn landfill gas. They
Much better with natural gas.
They're running, yeah. They don't get a D rate on natural gas, but the efficiency is exceptionally high. And as a matter of fact, I'm looking. I got a meeting tomorrow to talk about the Jenbacher project down in Mexico with a local company, Agreco, and we're going to do a heat recovery job.
The biggest they make is like a 10 megawatt unit, or they get bigger than that?
Well, yeah, 10's the biggest that you can have, that you can move around fairly easily.
Yeah.
Okay.
Yeah.
They build bigger engines. The cathedral motors go up to 50 megawatts.
Wow.
You know, but those are,
they're a little harder to move around.
yeah, you might find them in the belly of a ship,
Yes.
but they're running on number 6 all.
Wow.
Yeah, so, yeah, natural
And
gas.
that
Well, some of these
General
LNG
Electric has acquired the Jenbacher rights for this,
Yeah.
I guess all over the world.
Yeah, GE now owns Jenbacher, and they were, I guess for the most part, Caterpillar pretty well had most of the engines that landfill gas ran off of, and Jenbacher wanted part of that market, so GE went after them, and so that's really where that's coming from.
Wow.
I mean, from what we understand.
Yes, yes, yes. And they would power something like a hospital very well, or a large hospital, or a casino, or something like that. Somebody could self-power with that much more efficiently than paying peak demand power.
Yeah, I mean, the ideal thing to do for a casino or a large hospital is to put in a generator with a waste heat recovery system, local generation, get up in the 90% efficiency range and do it all day long. We tried doing that with the VA, but you know what happens there. VA was, we met and talked about doing that for them with several facilities.
Was this, yeah, they have a big one in Shreveport.
Well, we didn't get to go to Shreveport. We did do the study at Little Rock, Arkansas, and unfortunately, the problem they had was we couldn't get enough gas downtown to run the engine for them. That's what stopped it.
Wow.
But yeah, that's exactly right. You do local distributed generation with ultra high efficiency equipment. And that's generating electricity, making
somebody
water.
that's paying peak demand is actually paying 10 or 12 cents in Louisiana or more. And this self-generation, are you talking about half of that or a third of that?
Well, the bigger the facility, the more they can contribute.
Yeah, right.
But a small city could offset their entire peak with something like that.
The city like Abbeville, that's 30 megawatts.
Yeah, they could do more than just
Yeah, cool.
offset peak demand.
You on the air? Can we help you?
I'm on the internet, and I've got Luke on here, renewable energy opportunities. I
Yes.
have no volume. Can you help me there?
We can hear you very well, sir. Well, you have no
Okay,
volume on the station?
Yes, that's correct.
All right, well, thank you for calling in, and we'll see if we can get some help on that. Thank you, sir.
Yes.
We've heard complaints about that, so
Sounds like my buddy from Memphis.
so it's kind of with the energy world changing so drastically. You look at the numbers, it's phenomenal. When I think 2016, 62% of the new generation power in the U.S. was renewable, and in the world it was 68%. And those numbers, and it's going that way for one big reason. I think it's not about global warming and all this; it's about cost.
Necessity and cost.
Necessity and cost. And then we have a world that is smaller needs in third world countries the concept of building a 2,000 megawatt plant and then putting a network of 100 miles of wiring around to make it work, it's just beyond the economic reality of these third world countries. So smaller generation capacity, but brings you to solar and wind and other opportunities.
Yeah, I mean, there are all kinds of solutions that are at your fingertips. Distributed generation makes a lot of sense because you don't have all of these power lines that you've got to run, just to
With big line loss.
big line loss, exactly.
Yeah.
And but I have a book I'm going to share with you someday. It's the 1903 Steam Engineer's Handbook. It was written by the professor at Ohio State University.
Is that still the Bible of steam?
Well, I'm going to tell you what, you'd be amazed at how accurate this old book is. But to be honest with you, we're just going back to what we had back. I mean, the necessity is the mother of invention. Back in the old days, you know what powered the street lamps? Sewer gas.
Wow.
That's how everybody's street lamps were powered. They were connected to sewer gas. You go up there, you crank it up. You open the valve.
They were just gas from the sewer mains.
That's exactly right.
Wow.
That's everybody's street lamps. You had a if you go back and read about where all the ice plants came from, well, they were back of the old generator. As a matter of fact, we got one over here. If you head toward Generette, there's an old power plant right there on the Tesh. I walked through it a while back and looked at it, but they had an old steam boiler there. It was powered by an old locomotive type engine, made electricity, made DC power, ran the trolleys up and down Generette. They had the ice plant in the back. There was no.
They had trawlers in general.
That's what it was. So, but that was, back in the day, and I think it may have been even powered by bagasse or sugarcane. I mean, it was part of one of those mills.
You had two of the mills right there.
Right.
I think they both closed now. You had one on the east side of town and you had one on the west side of town.
That's
Yeah,
correct.
too.
And those techniques, that's one of the reasons I was very interested in that book is, and because they used everything they had, and they recovered as much energy off of it. I mean, making ice, running an absorber is a very easy thing to do. Right now, I can tell you, we in Hawaii, there's some people here in Lafayette, when they say they're going to Hilo, we make power off of macadamia nuts.
Very expensive power.
Absolutely.
Like 30 cents a kW, isn't it?
No, 60.
60 cents. Wow. And
Yeah,
we
in some cases.
we're about 10 cents here, so that's 6 times the power.
That's correct. And if you eat Mauna Loa macadamia nuts, we've powered that plant off of the husk and the shells. We generate the steam to dry the nuts, but then we also take the waste heat and make the refrigeration for the chocolate and the nuts before they're shipped out. So I mean, there's no waste out of that facility, and they make enough power. They don't buy any from the local utility, and then we also have a backup for them if they need. They can run off of waste engine oil and some diesel generators, but the majority of their power comes from.
So you're dealing with a lot of companies that are self-generated.
Yeah, they have to.
Yeah. Yeah.
To stay competitive,
Yeah.
they have to.
Yeah. Big cost side. Excuse me.
Yeah.
And there are certainly opportunities in Louisiana. We have all these energy sources. I mean, we're sitting in fabulous wind area. We certainly have waste heat generated by the gas processing units. Gas
Absolutely. I can't
processing,
see how Louisiana would have an energy problem. With the wind we've got, the chemical plants, and all the reject heat that we have in this area, we should be generating all kind of power
At very low cost.
at very low cost.
Yes, yes. I guess the chemical plants, the offer opportunity is certainly there too.
They do, but a lot of them have
How about
taken
from
their
the refineries too. The refineries have waste heat opportunities.
refineries have tons of waste
Tons
heat.
of waste heat.
absolutely. And I know of several plants out in the area that have actually taken their cogen systems offline because they were offered, or lower cost electricity. But and I'm talking about 50 megawatts. 50 megawatts is a lot. It's power of a small town.
Yeah, Abbeville about 30, New Iberia was about 50. Morgan City, I was with the mayor 2 days ago, they had around 40, 45, so 50 megawatts.
Yeah.
Yep. Now, what Morgan City did, they have a 64 megawatt combined cycle unit,
Mm-hmm.
and they tied it to MISO, so when they power in more than they need, they sell it to
They
MISO.
offload.
So it's become a source of revenue
Yeah.
far beyond their customer base.
Yes.
And,
Yeah.
and it's so, in lieu of taxation, they make money on a overcapacity on a very efficient system.
Yeah. Cash register runs the right direction.
It absolutely. And, in that, example, maybe some opportunities for Lafayette.
Well, there are several opportunities in for the Lafayette area. I mean, with all the work that's going on in Lake Charles right now, there's a couple of opportunities to generate a whole lot of power. And
I
off of waste
understand the power availability from the new gas to liquids plant that the South Africans are running. That it's over 1,000 megawatts.
Yeah.
And it's low cost power because it's waste heat recovery.
That's right.
Wow.
They will not fire an ounce of fossil fuel to make that power.
Wow.
It's waste heat.
And that's renewable. And I met with Mike Francis 2 weeks ago on this issue of renewable energy credits, which we don't have in Louisiana, and which is something that varies a lot in price as the world market.
Right.
At times it's more valuable than other, but it's kind of just extra profit just falling from heaven, so to speak. If you have it, it's in place, it can be a significant source of additional revenue for a community, for instance, like Morgan City. 40% of that power unit is waste heat recovery, so that's subject to renewable credits.
Yeah, and Harold, I'll have to admit I'm no expert on renewable credits because the majority of our work that we have done it pays for itself. So we've really never had to go get a tax credit because everybody, there's a profit made off of the stuff that we've done for everybody.
What you've done is people are significantly lowering costs, improving reliability, doing a lot of things. I mean, if you self-generate, you don't have to worry about the power lines going down, do you?
Nope. And
when a hurricane comes, you really don't worry too much about it.
No, that's right. There's a lot of truth in that, and you may not run 100%, but you can keep your equipment safe, and you can keep it powered up, and you can make it a whole lot easier to bring back online when everything else comes back online to support it.
Sure.
And that's without a doubt. So it's the ability to self-generate off of your own waste is a huge opportunity. And then if you've got some other source of waste that you can obtain,
like for instance, the gas plant right there in Burbridge, it always got a flare blaring. You don't need lights in Burbridge. The flare is taking care of it. Why wouldn't that company just hook to a steam turbine and sell power to MISO, whoever needs it?
Well, a couple of different reasons. One, their energy cost is maybe, and I'm going to say inexpensive, because some of these big facilities do get a lot lower price for electricity than you and I can pay for it. But what happens is sometimes that flare is a safety device, and they've got to keep it lit. So if there's a problem with the facility, they can offset or send the gas.
Dealing with toxic gases.
Right. But what we have done here lately is the EPA's come back and said, you need to find a better way to deal with that. And we've been working with a company in Houston, and we are shutting down 2 huge flares, and we're going to be generating the equivalent off of one flare about 5.5 megawatts, just off one flare.
Uh, to give people an understanding of what a megawatt is, that powers 900 homes.
Yeah, roughly
So
900.
you're talking about almost 5,000 homes in terms of revenue savings or whatever you want to call it. That's very significant.
Yeah, and in this particular project too, it's going right into their steam generation, which we're generating their steam at about 81% efficient, and then it goes into a direct use. The steam goes into a direct use project where it's condensed back to water, so there's no reject. So the overall efficiency of this waste gas is extremely high.
Wow.
So, and that's where a lot of that stuff makes sense.
Yes, right, yep, absolutely. One of the things is that I think we have 28 states in the country have a renewable energy requirement. And we need to have one in Louisiana. And it what it does, I don't think it would be a burden to industry, whatever, because it's achievable in a lot of ways. But it would focus on it, and it would kind of require businesses, industry, communities to look at this renewable energy requirement and move into the modern energy world that is definitely going in that direction. And it's going because of lower costs. And you know, for somebody of means, the electrical bill is not anything important. But to poorer families, that electricity bill is an enormous burden. And you know it, a lot of people have their lights cut off and so forth because they can't afford to pay the electricity. So lowering rates is very important to the community.
Well, you know, one of the things that we see is if you can give business, then, you know, if you can encourage them to do something, they're going to do it way faster than if you force them to do it. And because the minute they're forced to do something, they're going to find every reason in the world not to.
That's right. But you look at Texas, they came up with a 2% renewable requirement. I think it was in '98. And they had 5 years to do that. They did that in a year and a half.
Right.
I mean, once they got into it, realized that this wind power is great, it's low cost, it's, you know, green energy. I mean, Austin Energy is one of the first communities really went into this, where they started offering wind energy contracts to their customers.
Yeah, and you know, we were a little part of that. We got our small part of that. I mean, we helped the city of Lubbock, Texas, repower some of their equipment so that they could, you know, offset peak demand when it was necessary, and they got very low cost electricity. I think they had 100 megawatts came on in their backyard and, overnight, just about.
Wow.
And so those projects work exceptionally well. And, you know, the solar projects too, I mean, are becoming more and more viable.
The technology with solar is so much improved. You know, the old technology was 6-8% efficient. The new technology is 42-45% efficient. Solar was at 6.5 cents a kW. Now it's 2, is right there. You get combined cycle gas. Wind is the cheapest. Combined cycle gas, and then solar, and they all next to each other. They're all within a half cent in that range. Then you got coal, double or triple that amount.
Right.
And so coal, I mean, the president can holler and hoop all he wants, he's bringing back coal, but it all comes down to people paying for it. And when you're paying double or triple, people are just not going to pay for it.
Yeah, and coal, you know, we do work with coal equipment, and it's tough. I mean, it's, you know, it's you're burning a rock, and you know, dealing with it.
The emissions are a major problem. The waste is a major problem.
Yeah, and there's been a lot done with it, but at the end of the day, we have plenty of energy sources available to us that we can.
But we don't have to all from Gillette, Wyoming.
No,
I mean, you look at Lafayette, at the time that the decision was made, probably was a good decision, but times have changed. And it's really time to move on into less costly, environmentally friendlier technologies. We have
Yeah.
a call. You on air? You on air? Can we help you? Call didn't come through. I guess he'll call back. So, I would like to see that issue come up before the Public Service Commission, that we have maybe a 1% requirement,
Yeah, you gotta start.
Yes, you gotta start.
And you need to get a flavor for it, and you need to understand what it's like.
Yeah.
Because, I'm gonna give you an example. We became part of the Energy Conservation and Resource Conservation Initiative for Frito-Lay 10 years ago. And I can tell you right now, they're saving better than 10% of their total energy costs compared to where they were 10 years ago.
And this is for their nationwide facility.
Yeah, this is for their nationwide facility, and it's all to do with heat recovery, alternate fuels, using water. Man, we're sitting here talking about energy. Water is going to be the next biggest thing we're going to sit here and talk about, and a lot of energy goes into making water. But that's also part of their conservation initiative. And conservation is a big part. If you can go from 40% efficient to 80%, you just reduced your energy consumption by half, and CO2 production by half.
Yes, absolutely. And it's tied together with, clean air issues, no question about
It's
it.
directly
Directly
tied to it.
tied to it,
You burn half the fuel, you make half the emissions.
Yeah, absolutely. You look at the coal-fired plant we run, the cost of that electricity from 2014 to present is went up about 30% in 3 or 4 years. It is still continuing to rise. And at that same time, the cost of wind, the cost of solar, the cost of combined cycle gas, all of that's going down.
Right.
Technology is better, and we move into more efficient grid systems. Texas, for instance, uses more and more direct current transmission, send it power long distances without these horrendous losses. And Louisiana is one state in the country that doesn't have a mile of direct current transmission.
And with DC power, and with today's electronics, stepping or rectifying to DC, transmitting to DC, and then inverting it back to useful AC power, there's so little loss in it.
The efficiency of that
The
transfer.
efficiency of that transfer is
Yep, right. And
significant.
then most of the turbines, the wind turbines now can produce AC or DC. So they just produce DC.
Right.
And then they go, so there's one transfer less.
Yeah, you have to. Yeah, you take it. Most of the wind power is done in DC because it's not.
It's long distance shipped.
Well, that too, but you don't have to worry about. The generator itself is going to run it. Depending upon wind speed, it's going to vary in speed. So it's much easier to produce DC power
Really?
instead of trying to run it at 60 hertz.
Yes.
You can't generate it at 60 hertz AC because.
So there's a big advantage right at the get-go.
Yeah, the turbine becomes much simpler because otherwise you got to have just like an airplane in reverse, the prop spins at various speeds, but the generator's got to run at one speed.
Yes.
So instead of having a constant speed engine and a variable speed, a constant speed prop and a variable speed engine, you got to go the other way around. That prop's going to turn depending upon wind velocity, all kind of speeds. Yeah. And if you got it hooked to an AC generator, the frequency is going to go all over the place. So that's why it's easier to do DC.
Yeah, and then they don't have this big line loss. So
yeah, and it's complicated.
And I understand a lot of those wind units now are putting in solar panels too, because they already have all the plumbing to move the power.
Right.
So, and that's why Nexera is such a profitable company.
Exactly. When we did work with the Clean Air Congress, we learned a lot. I mean, I was a lot, when we listened to what the Japanese were saying, because, yeah, when the wind's not blowing, the sun's shining. So you couple
That's for
solar
sure.
with wind, and
I
you got
appreciate-
the answer.
Yes.
Because the solar makes a lot of sense, especially during peak generation, because
That's when
that's when everybody
Everybody's
needs
got-
it, and the
yeah,
sun's.
air conditioner, everybody's running their computer, pumping their gas, and on and on.
That's right. And so if you couple wind with solar, then you are, getting the best of both worlds.
See,
Please hold while I try to connect you.
see if we got a call coming in. That call didn't make it. So when you look at Lafayette and we are at a turning point, do you see, we run about 400 megawatts, so the old plant is about 300 megawatts. And so I could see a future that could tie us to solar, to wind, to waste heat recovery, a long list of renewables.
Yeah, and
That's right out of our back door. Literally, the Sasol plant, Lake Charles, is only 70 miles away. I mean, no big deal. If you could DC send it, to Lafayette, it'd be, tied to those folks. They thought they would sell power in Texas, but Texas won't allow that to cross their border.
Right.
They will not. I kind of laughed when the big generation company in Shreveport, Schweppco, was cooked into an Oklahoma wind project that was 2,000 megawatts, and they planned to sell 700 megawatts in Texas. And I thought, Texas PSC will not let that happen, and they did not.
Right.
You know.
Yeah, and Texas has about 2 gigawatts of coal that's up in the northeast corner that is fixing to play out,
And they got the energy plant at Beaumont that's still coal powered.
right. But you know what? They're not too worried about it because they've got plans to offset it as it goes offline. I mean, it's without a doubt they're positioning themselves.
They have a big customer base in that area.
Well, yeah, I mean they feed Dallas,
Yeah.
so yeah, that's all those old fields out there in northeast Texas, the coal mine. It's on it. It's at the end of its life.
These
coal
are
is.
lignite, lignite. And
Yeah.
I think Cleco's looking at closing the Dolet Hills facility. That's lignite coal
Mhm.
up near Shreveport.
Yeah, I'm
That's
pretty sure that
supposedly,
does
that
happen.
is supposedly the filthiest running power plant. I think it's 600 megawatts or 660. That's the filthiest plant in the U.S.
I wouldn't doubt it. I mean, it's
that's according to our PSC figures. So.
yeah, coal does.
And
You
look, are you keeping track of what Duke is doing with their nuclear power plant, I guess, in South Carolina?
No, unfortunately, I
They have
haven't.
$58 billion. They're not finished yet. And then a similar debacle is Kemper Coal in Mississippi, which was a clean coal. This is where you take coal, you gasify it. That's a very expensive process. You had $18 to $20 a million BTUs, and why would you do that if you can buy the gas out of the pipe for $2.50 or $2.75? And that's exactly what's happened. They started with a $1 billion grant from the Obama administration for the gasification of coal. Once they got the gas, they run it to a gas turbine, just like natural gas,
Right.
or landfill gas, whatever. and so they're almost $10 billion. That project will raise the rates in Mississippi 55%. Which again, you look at Mississippi and Louisiana, poorest states in the country, and who you hitting the poor people.
Right.
When you raise their rates 55, you're literally taking food off their table. And it comes a choice, you have air conditioning or do you eat almost,
Right.
And so I think,
And that's two heat
the
recovery
goal,
opportunities.
yeah, the goal of our PSC, the goal of Lafayette should be to lower the costs and take advantage of all the technology that would guarantee us lower costs.
Yeah, the technology, you know, it's just like your old car. You know, old car's still an old car, but that same old car, instead of getting 5 miles to the gallon, the equivalent car today gets 24 and 26.
Yep.
It still looks the same.
Yep.
It's all about the technology. It's just made to run more efficient, and it's no different. Generating power, you know, if you do it wisely, there are technologies out there that can produce low cost power.
I stayed as a friend of mine as an author, a writer. He's become very prominent as a writer. He has a country home, kind of on 160 acres near Paonia, Colorado. Real pretty little valley. Produces a lot of fruits and grapes and peaches, and very productive little valley. Beautiful, kind of in west Colorado. And his home is totally off the grid.
Okay.
And this is his own innovation. He hooked his solar panels to 8 trolling motor batteries
Okay.
with an inverter.
Okay.
So he converts it all to 120. So he's got a few 12-volt things, but he does have a 12-volt light system, but also has the 120 system. But he's running his refrigerator, freezer, his coffee maker, everything you run in your house. And there was a balancing issue at first. If he stayed at the house a month or two, the battery set would eventually go down. So he increased his panels 300 or 400 square feet, and now it never goes down. He can't, use it all. And his first battery went down after 4.5 years. And he said, when it went down, they all 4.5 years old, I changed them all. And he said, they're about $100 a piece. So that's his only cost. He's 3 miles from town, so he gets his water from town. He's got butane tank out there, which he heats, and he has on-demand hot water. So that system only goes on when he has a need for hot water. So very, very efficient system. He says around 150 gallons of butane a year. And so we're getting closer and closer to technology that allow you to pretty much self-generate.
Oh yeah. Well, right now I have a problem at Sipmore Point. You know my boat dock. Well, I have a hoist out there on the end of it.
Yes.
It's 1,200 feet away,
Oh, yes.
and I need to repower my boat dock. So what I'm gonna do is I'm gonna put a solar panel out there on the top of my little shack and charge the batteries so that I can put DC motors on my.
We have an interesting option. Yeah, DC motors. That's what starts your car.
Yeah, they are.
That's all we'd use.
That's exactly what I'm gonna be using, the motor starter.
And I think a battery in an electric car right now has a life of 6-7 years, 70,000 miles. Now those batteries still have a lot of use in them, and so there's companies being put together to collect these batteries and use them as storage. And they're changing them because your range drops. The battery will still move your car, but you have less and less range.
Right.
But there's a lot of restored power left in that you could, take solar power and store it, just as the guy in Colorado does with his. He's getting,
Yeah, a lot of life out of those batteries, and there are new techniques for recovering a lot of that loss out of those batteries today too. I know I've got a couple big Caterpillar, engine batteries to start a couple Caterpillars, and they were dead for most purposes. But I had a little buddy of mine say, "Here, this is what you need to put in them," and now I've got about 70% of the life back out of them. These batteries are probably 20 years old.
Do you change the water in them? What do you do?
Yeah, you change the water and reactivate the cell, and it cleans them up, and I'm getting about 70% of the capacity back out of it.
Are you using distilled water, or you using tap water?
No, you got to use distilled water. Yeah, that's the problem. The minerals, in the water is
It
what
causes
plates. Yeah.
it messed up the
It reacts with the plates, and that's what, yeah, you have to use distilled water. So, but yeah,
I
there are a lot
worked
of ways
with
to do
an
it.
interesting inventor up in Ottawa, Fred Ferguson, and he's a dirigible aeronautical engineer and designer, and he was wrestling with the problem with a contract with the Canadian government to deliver heavy loads of fuel to remote sites during the summer. During the winter, they can drive on the rivers, but during the summers, they couldn't get fuel. So, and just because of the necessity that a dirigible has to be super lightweight, it can't carry much weight. So he got to wondering if he spun this dirigible, if he spun it, if it would increase lift. And to his astonishment, it increased lift 250%. And so he could make it much smaller, carry the load successfully, move it much faster with a much smaller unit. And so then he realized this has a lot of torque. So he designed a generator that it, you know, it goes up by itself. It has helium in it, and it just spins. It only has
So
two
it's
moving
tethered
parts.
and-
It can go up 1,200 feet, and you know, I mean, wind turbines. You lucky if they run at 30% of capacity. These things run at 80% because they have a device that seeks the best wind in 1,200 feet. So it'll move up and down and find the best wind, you know, and very low cost.
Yeah.
Very, very low cost. And of course, it hadn't gotten to the market for whatever reason, you know.
Yeah, no,
But that technology is around. And he also realized he can make hydro turbines do the same thing.
Well, I was just thinking to say, you know, I'd like somebody to calculate how much power we could get off the Mississippi River. You got New Orleans and Baton Rouge. I bet you we could power both.
Look, we drove, my wife and I put in at St. Louis and came back all the way to Butte La Rose, took 4 days, you know, running 300 miles a day. That was a trip, but I can tell you, there's a lot of power in that river.
Yeah, no joke.
And you're running at 4 miles an hour. I mean, consistently runs at 4 miles an hour.
Right.
4 mile an hour current, probably 9 months of the year, maybe 10 months of the year. That's an enormous, and part of it is hydro turbines have been very expensive. Now, Ferguson's technology is less than $1 million a megawatt. Some of that technology is
That's-
20, 10, 12 million a megawatt.
Right.
So his technology is super, super low cost, just out of simplicity. So
Yeah.
that's been outstanding. So it's excited to have you with us, Luke, to share what Lafayette's future may be and the future for Louisiana. You know, I think we need to get off coal completely. We need to kind of follow Texas' lead and bring low-cost energy to our businesses, to our homes. And, you know, if you have the lowest cost energy in the country, you don't need a Chamber of Commerce.
Yeah, I mean, you're gonna bring people here. I mean, they're gonna come.
They will
You know,
absolutely come, and we have all the energy resources that Texas has, plus. The top wind resource in the country is the shallow waters of the Gulf between Southwest Pass on the Mississippi and the Sabine. Stanford University tested that in 2000 in a 3-year study. They had 1,850 test sites. 23 of them are category 7 premier sites, and 7 of those in Louisiana.
And
So we have the gold mine of wind, we have the
technology to put them up and keep them up.
We can
Yeah.
build the platforms and make it
Right.
all happen, so.
Yeah, I mean, we're not
Yeah,
drilling
be
for
exciting.
oil now, so,
And,
but we
you
got
know,
all these
we
resources.
we don't have to put them offshore, we can put them in the bays
Right.
where we're not dealing with 40, 50-foot waves. We
Right.
can deal with, you know, low cost to get out there as close. We can use empty pipelines, seem we have a lot of them now. Use those empty pipelines to bring the power in at much
Jack
lower
up
cost.
barges,
Jack up bar-
fabrication facilities.
All of that's available to make
Right.
it happen. The question is Louisiana in the oil business or are we in the energy business? If we're in the energy
Yeah.
business, we have an enormous future. If we're in the oil business, our days are numbered.
Yeah, and that's evident right here in our own backyard.
Well, that's happening now, is that interest is changing. I mean, it's at a peak, but the peak is not happening here. It's happening in Texas where your people are, in New Mexico.
Yeah, you know, I really enjoy our business, but you know what? We have to go to do what we do. We do it in
Right
almost
here.
all the other states. We don't do it in our backyard.
And it's a
That's
shame, we
unfortunate.
should be doing it here. We have the needs here, we have the resource here, we just need to have the will to do it. And I think maybe renewable energy requirements would just maybe tip the scales and force people to look at it probably in a friendly way.
Except for the biomass work in Louisiana, which that's been,
That
Going on
Lafayette's
for
ideal
years.
for biomass, we got, literally tons of it. It is available all the time. The grass grows when the rain comes, the hurricane comes, we produce more and on, so.
yeah.
So with that, thank you so much, Luke, for being
All right.
with us and sharing your knowledge and experience for the last 20-plus years and bringing low-cost energy to lots of communities. And
Thank you lot
hope that
very much.
experience can help guide us in a good direction in Lafayette.
Well, it's it's in our backyard, and we definitely want to do the best we can with what we've got. Everybody needs to.
Maybe look at Lafayette Renewable